such restless waters as these, the Gulf of Mexico, lie the oil fields of tomorrow. Oil fields discovered and developed to meet the tremendous upsurge in demand for petroleum and all its many byproducts. This is a story of oil taken from under the sea, a saga of oilmen whose vision and courage mastered the barrier of ocean currents, waves and tides, of hurricanes and other relentless forces of a restless sea. Men of skill and determination, pressing their search for oil ever seaward. First 1 mile, then 5, 10, now 20 miles, and tomorrow who knows how far from shore. This seaward search for oil had its beginning in the historic Evangeline country along the Bayou Teche, an area immortalized by the poet Longfellow in his idyllic tale of the Acadian people. An area transformed from a quiet pastoral community into an industrial center alive with new activity. It had been found that great mainland oil fields extended under the partly submerged marshes and shallow swamplands, under bays and quiet bayous, down to the ocean's edge. Should not these same conditions exist beyond the shore, throughout the continental shelf? Thus reasoned scientists of the petroleum industry. A logical theory, whose proof was to involve new and complex problems. The first venture into the open waters of the Gulf in 1938 at Creole, a mile and a quarter off the mainland of Cameron Parish, Louisiana. Working in the 15th water, another operator built a large wooden platform affording space for practically all conventional drilling equipment. The discovery at Creole resulted from seismograph work started on the mainland, continued and extended into the open sea. Here, through directional drilling, 10 wells were drilled from a single platform, and in the first 11 years of operation produced about 2.25 million barrels of oil. Pressures of war delayed search and development in the tideland areas. Short steel supplies were concentrated on proven locations in older fields, where a barrel of certain oil was worth more than any speculative venture of greater possibilities. The fantastic post-war increase in petroleum demand revitalized the search, forced the industry into an urgent, dynamic quest for new fields, new production, greater reserves. It was time to replenish the stock of America's greatest natural resource, to find the oil for our industry and commerce, to supply our vast transportation system, to heat our homes and offices, to build a stockpile for any future emergency, to find the oil to meet a domestic demand in excess of 6 million barrels a day, to block out the reserves to support this economy moving on heavy wheels, borne on silver wings, to power and lubricate the grinding gears of industry. Spurred by these many factors, executives like these, Robert S. Kerr, United States Senator from Oklahoma and president of Kerr-McGee Oil Industries, Incorporated, and Dean A. McGee, executive vice president, turned their attention to the task. Here, they reasoned, was a potential oil country of 51,000 square miles, an unexplored petroleum province under the sea. Here, hidden beneath fog, rain, and restless ocean waters, the continental shelf extended seaward to water depths of 600 feet, and, so far as scientists were able to determine, contained subsurface formations that would be favorable to the bountiful production of oil. Here, undoubtedly, were salt domes, exactly like those protruding upward through sedimentary rocks along the mainland. Salt dome structures similar to the hundreds producing oil in the proven fields fringing the Gulf of Mexico. Accepting this challenge from beneath the sea, an intense series of conferences got underway to determine costs, consider the hazards, to estimate the possibilities of success, not in terms of this year's bank balance, but over the long-range viewpoint. These problems exacted the utmost in vision, courage, and technical skill, calling to the full on the abilities of executives, engineers, geologists, drillers, to map the strategy for a great offshore venture. Field men studied textbooks and reports to see how related problems had been handled by others. The records of Gulf tides and storms were combed to determine the requirements of structural design. Winds and currents, the minimum and maximum of water depth, all of these were studied. Possible oil-bearing structures had to be located. For this purpose, new techniques in the science of seismology were developed. One of these was the application of SHORAN, a wartime development of navigational radar to determine the exact location of each shot point. At known U.S. coast and geodetic reference points ashore, 2 portable signal repeater stations are precisely positioned. A survey vessel can then compute electronically its exact distance from each station and, by triangulation, plot positions with pinpoint accuracy. The shooting boat and its companion, the recording boat, are ingeniously equipped to record and measure reflected shock waves created by discharging dynamite about 5 feet below the water surface. These controlled explosions set energy waves in motion, which, when reflected by the various hard strata, are picked up by geophones strung out behind the recording boat. The varying impulses are then transmitted on waterproof cable to delicate recording instruments, and the photographic record interpreted to reveal structural conditions thousands of feet below the ocean bed. The acquiring of leases followed preliminary geophysical exploration. Tideland areas are leased by the states concerned. Louisiana's in blocks of 5,000 acres. Prices are high, bidding spirited. Kerr-McGee and their associates took up thousands of acres in such leases. Their Cameron block, consisting of 4 5,000 acre tracts, purchased by sealed bid. An area of 20,000 acres for which a bonus of about $400,000 was paid the state of Louisiana, together with a royalty if oil is found. The availability of marine equipment had to be explored. War surplus stockpiles visited and inspected, all for the ultimate objective of designing the most adaptable, most economical and efficient unit for drilling at locations covered by 20 feet and more of open sea. Kerr-McGee acquired surplus boats suitable for adaptation to the specific job. Navy YF barges for conversion into drilling tenders. LCTs for transportation of heavy material. Air-sea rescue boats for movement of personnel and lightweight supplies. Vessels which had each contributed to a great military victory were once again pressed into service. Battle scars removed and converted to meet new requirements, they were prepared for another great task, the search for oil, the strengthening of a peaceful world economy. At the same time, there began a gathering together of drilling equipment, specialized tools and machinery of proven ability for a new venture far at sea. From every corner of the country came necessities, all the multitude of pumps and tanks, of engines and drill pipe, all the varied component parts to fulfill the specifications of skilled engineers to construct a completely self-contained drilling unit 41 miles from the nearest land base in the open waters of the Gulf of Mexico. a unit designed for the conquest of new fields, the kingdom of Father Neptune. A result of months of research, a tremendous investment, and the utmost in engineering ability. A culmination of vision transformed to practice, of concept to final design. A materialization of careful planning coupled with efficient teamwork. This drilling operation far from shore, this extension of the search for oil, requires on-the-spot logistic support. The drilling tender, originally designed as an advanced base supply vessel with a cargo capacity of 2,300 tons, was converted for this purpose at a cost of more than $300,000. With an overall length of 260 feet and a beam of 48 feet, it is ingeniously employed as a headquarters, hotel, and floating warehouse for the storing of drilling supplies and provisions for day-to-day use. Because of the distance from land, 2 complete drilling crews are maintained aboard the barge at all times. On a continuous operation, each crew works 12 hours a day for 7 days and are then relieved for a week ashore. Some of these returning crewmen travel as much as 500 miles from their homes, but on the job, they also find many of their accustomed comforts. Pleasant bunk rooms and comfortable beds are well appreciated after 12 hours of strenuous, demanding work. Of equal importance to the crew members is the pleasure of a well-equipped recreation room. Chow call promises heavily laden tables piled high with meats, vegetables, and desserts. The chef gets his day's provisions from well-filled shelves. At least a week's supply is kept on hand at all times. From the frozen food locker, he gets steaks, pork chops, chicken, enough to satisfy seemingly insatiable appetites. For an energy-consuming job fanned by a salt breeze really makes a man want to eat. Heart of the operation, the barge is a beehive of activity. Located on the lower deck are the electric generators, skid-mounted cementing pumps, mud pits, mud pumps, dry mud storage, chemical supplies. Atop the upper deck are the pipe racks, electric logging equipment, spare drill bits, a full complement of auxiliary tools, cranes to facilitate offloading of supply barges, to move the heavy equipment and materials needed in deep hole drilling operations. Equipment of great strength and durability is essential in all marine activity. The drilling structure, brawn of the operation, is erected upon a relatively small, rigid platform supported by 8 30-inch steel piles driven deep into the ocean bed. The main deck or substructure is attached to and built around the piles. Installed here are the drilling engines, mud pumps, mud tanks, and day tanks for water and fuel. A steel superstructure serves as the derrick footing and forms an upper deck or derrick floor, support for the big Idaho 1350 rig. The rig is powered by 3 GM diesel quads, 72 cylinders delivering 1,800 horsepower to operate the drawwork, rotary table, and mud pumps. Like a master at the console of a great organ, the driller controls this massive machine by manipulating air valves mounted on a central control panel. He watches gauges and meters, knows exactly the weight on the drilling bit. Power distributed by the compound unit is delivered through a transmission to the hoist and rotary table in any one of 9 possible combinations of torque and speed. Air-actuated clutches control a single hand wheel at the driller's station determine the speed. Gears and bearings of the rotary table are thoroughly lubricated and are protected from mud by means of a sealed oil bath housing. As drilling progresses, the bit becomes worn and a new one must be substituted. All drill pipe must be pulled from the hole. First to come is the Kelly and swivel. Slips are placed in the hole. Heavy tongs clamped on the Kelly, and the first joint is broken out. Roughnecks pull the Kelly to one side and lower it down the rat hole where it will be clear of action on the derrick floor. The traveling block is lowered. Elevators latched around the first stand of pipe, and the driller picks it up with the drawworks. Breakout tongs are applied. The rotary is turned to unscrew the joint, and the pipe is racked in the derrick. High up on the racking platform, the derrick man releases the elevators and racks the pipe in place beside the other stands, and the block is lowered again for another stand of pipe. Time and again, the operation is repeated until the last joint is lifted. Worn-out bit is removed and replaced with a new one. And now, all the pipe goes back into the hole and drilling is resumed. A most important factor in the drilling of offshore wells is that large volumes of fluid must be constantly circulated under high pressure. The mud pumps do the job. The Clark Idaco T880 triplex pump delivers more than 1,000 gallons per minute at 1,220 pounds pressure. Triplex action smooths out pumping impulses, maintains 2/3 less variation in discharge pressure than duplex action, makes it easier on prime movers, and lessens shock and wear on the entire system. On the barge, another pump mixes the mud and transfers it from the mixing pits to the slush pits. This mud, constantly circulating inside and around the hollow drill pipe, must be of controlled density. The weight of the mud counteracts tremendous underground pressures. It brings the cuttings from the bottom of the hole to the surface, washes and cools the bit. To keep it in good condition, the mud is constantly checked by specially trained engineers. Carefully watched is the weight, viscosity, alkalinity, sand content, and water loss. In deep sea operations, elaborate safeguards are essential. Typical of these precautions is the use of multiple blowout preventers installed between the derrick floor and the lower deck of the drilling platform. As drilling progresses, every prospective zone is tested. Electric well logging devices give an accurate picture of the permeability and porosity of each new formation. There can be no guesswork. Operators must know the possible oil-bearing sands as they are drilled. Every likely formation will be cored and examined. Study of cuttings reveals the exact nature of the formation through which the bit is drilling, so the geologist knows exactly when a promising formation is reached. When the oil-bearing formation is found, plans are made for the completion of the well. Casing is run to the bottom of the hole, cemented, and perforated. All is made ready to bring her in. The separator is set, the valves eagerly opened. Oil flows into the separator and, diverted through a flexible hose, goes directly into an oil barge for transportation to shore. Across the open expanse of ocean, up through winding bays and bayous, new oil moves to market. The first well completed, operators turn their attention to another, drilled from the same platform by means of directional drilling technique. At predetermined depths, special bits are employed, designed by security especially for the job. For the first few hundred feet, the holes are practically vertical. Then they are slanted as desired, to the east, west, north, or south. 4, 8, 12, possibly 16 holes from the same platform, all completed at spots accurately and precisely determined before drilling starts. To service this giant undertaking, a substantial land base is required, and at Morgan City, Louisiana, Kerr-McGee maintains its division headquarters. Here are located the field offices, supply yards, and the storage tanks to accumulate oil awaiting movement to refineries. A large fleet is essential in marine drilling. An average of 6 boats of various sizes and types being necessary for each active operation. At least 3 barges must be added to the marine fleet for each production operation. 1 loading, 1 in transit, and 1 discharging crude oil at the mainland base or refineries near the seacoast. A communication network must be maintained with the far-flung operations. Telephone lines are impractical, so shortwave radio is utilized. At the base headquarters, the master station is in constant contact with the drilling barges. Radio contact is maintained with the boats and barges plying back and forth through rivers, canals, and the open sea. Drilling in the Gulf of Mexico is undergoing constant change as new methods are evolved, tried, discarded, or utilized. Some companies use large, self-contained platforms costing upwards of $1 million to build. On these platforms are located all drilling equipment, crew quarters, supplies, and storage. Submergible drilling barges still are used in the very shallow water near shore. Drilling a well in the tidelands area is no small venture, sometimes more than $1 million to complete one. Gulf storms, fog, and rough seas must be combated. They cause expensive delays during the platform construction period. How seaward will the ocean oil fields extend? Gravity data indicate salt domes 75 miles from land. At least 100 salt dome prospects have been mapped off the Louisiana-Texas coast, yet only a small part of the area has been surveyed. Wells in the Gulf of Mexico have already been drilled to more than 14,000 feet. Men and tools pioneering the development of America's new undersea oil fields. Already they have accomplished miracles. They have transposed theories of geology into proven reserves, actual oil of inestimable value to every American citizen. Fulfilling its part in the progressive, competitive, and alert oil industry, Kerr-McGee explores for drills, produces, and refines petroleum, helping to keep the lifeblood of industry flowing in unending supply, constantly developing new and better methods to build a greater tomorrow. From the snow-capped peaks of the Rocky Mountains, across the broad prairies of Kansas, Oklahoma, and Texas, the company's operations now extend far out into the waters of the Gulf of Mexico. Here lies a potential inventory of vital petroleum being made available to present and generations by the men of vision, courage, and resourcefulness who explore Neptune's oil fields.